So in this assignment, we're doing some basic physics. We are propelling a projectile that we launch at a given angle, and we want to know what happens. If there was no attraction from the Earth, what would happen, of course, is that the projectile would just keep moving in this direction forever. But as you know, it does get attracted by the Earth, and so we expect that the real path will be something more or less like this. In fact, you've probably computed this in calculus and saw that it actually is a parabola. All right, so here's first the basics physics is if we have some speed sx, sy in x and y direction. Let's just think of some value here. Let's assume for the sake of the argument that it's 10 meters per second. And now let's suppose that we see what happens in 2 seconds. Well, then of course it's going to go 10 times 2 or 20 meters from where it was. So it'll be x plus 20, and the same thing will happen in y direction. So the idea is that we're going to be running this for a fraction of a second actually, because in the computer we can, for a lot of times, and each time we're going to be updating the x and y position. Like I said, if there was no change to the speed, then it would just putt around in the same direction forever. Now when the speed does change, we need to update the speed. The speed changes in exactly the same way. It depends on the acceleration. So we update the speed to the original speed and then times the acceleration multiplied by the time interval. The acceleration of the Earth is minus 9.81 meters per second squared. When we multiply by some number of seconds, then so if you multiply this by seconds, then this unit cancels, and you get some meters per second, so you get some speed difference. And that tells you how the speed changes. So that's the math behind it. And now what are we supposed to program? We're supposed to implement a constructor that takes the initial height, the angle, and the speed. Oh, what was with the angle? If you have a particular angle that tells you how to distribute the speed into x and y direction. So in this situation here, this here is v times, let's see, so x direction is sine, and in the y direction it's cosine. And again, that was given to you, so you weren't expected to come up with that math. Is it cosine or sine? I can never remember this stuff. I think I was wrong. All right, so it is this, and so let's have a look at how this constructor is implemented and how the move method is implemented. So here's the constructor. Oh, I should first say, what are we doing to represent our particle? It depends on 4 different items here, namely the x and y position and the x and y velocity at the time. Actually, the x velocity doesn't change, but still, we need to remember the y velocity does change through gravity, and the x and y position, of course, do change. So we start out at x equals 0. That was given to you. The y position is the launch height. And then here you have the velocities where you multiply with the cosine and the sine. The only thing to pay attention to is that in the constructor, unpleasantly enough, the angle was given in degrees, but the math.cosine and math.sine function don't want degrees, they want radians. So you have to do that conversion. Now here's the update. This is exactly from the formula in the problem description, and so is this. Like I said, the x velocity doesn't change. And then we have the position method here. Now there's a slight wrinkle here. Instead of, we could have had a method get x and get y, but I wanted to show collaborating classes. So this is the very first example where you have to do 2 classes. And so here's the point class that you were asked to do. So here's the constructor for the point class. And then when we look at the point class, that class has the getX and getY methods. So this point class is of course an utterly trivial class. It just collects the X and Y position. It has a constructor that sets them. And then it has the getters for these. In this particular example, there was probably no great reason to have the point class. One could have just added the getX and getY methods to the projectile. But in general, it is actually quite nice to have a point class. It makes it possible for you, for example, to collect points in a list instead of having to have separate arrays for the X and Y positions. And so it's a good habit to get into. Now, when you run this, then you do see the parabolic shape here very nicely. And what's impressive about it, there was no calculus inside at all. You see the parabolic shape with nothing but basic arithmetic. So look in the projectile class. All we did is update the position and the velocity, and just by computer simulation we get the parabolic shape. And that's actually a very powerful method. As it turns out that over here we've assumed that the gravity is constant, but if the projectile flies quite high, the gravity will be variable. And the first computers that were built in the late 1940s were actually built to do exactly this calculation, to be able to compute the trajectories of projectiles with variable gravity, which calculus did not have a good solution for, and so they needed the computers to approximate that.